Welcome to the Are You GCSE Physics Ready playlist. This playlist is packed with example questions and guided solutions for every GCSE Physics topic. So it's the perfect tool to help you test your understanding. If you feel like you might need a quick review of this topic before having a go at the questions, or you would just like the ideal revision companion for these videos, then do make sure to download my free GCSE Physics revision notes, linked in the description below. If you're ready, let's dive in.
Okay, so let's start these decay equations for the one on the left, fluorine. So we have two lines of maths basically that you're going to do. You're going to look at the top line of numbers and you're going to look at the bottom line of numbers. So we're going to start with the top line. So I'm going to write 18 on my left hand side with that fluorine is equal to, remember any sign with an arrow here is just going to be equivalent to an equal to sign. 18 over that oxygen plus something. So that something is obviously going to be 0 because 18 is 18 plus 0. And then the bottom line of maths, we have 9 is equal to 8 plus something. So that something must be plus 1. Then it's up to us to decide the nature of that radiation. So that's based on the fact that there's a top number of 0 and a bottom number of plus 1. And I know that my beta plus particle is the particle that has those two numbers. Okay, next question. Plutonium to uranium. So we've got first top line, 238 is equal to 234 plus, well, that should be 4 at the top there. And then the bottom line, 94 is equal to something plus 2. So that bottom bit there should be 92. Okay, next question, my carbon one. So top line, 14 equals something plus 0. So that should be 14. Bottom line, 6 equals something minus 1. So that something must be 7 because 7 minus 1 is 6 there. Okay, final one, top line 99 equals 99 plus, well that will be 0, and bottom line 43 equals 43 plus 0. So two zeros there, and then I need to decide what is the nature of that radiation, and it is gamma with 0 mass and 0 charge. The only other one that they could get you to do in these decay equations is use a neutron. So you should know that that has a symbol N and has a top number of 1 for its mass and a bottom number of 0 because it has 0 charge. Okay, bottom left question, what happens to a parent nucleus in beta minus decay different to beta plus decay? So let's write out both decay equations. So in beta minus decay, you have a neutron turning into a proton and releasing beta minus. Whereas in beta plus decay, you have a proton which turns into a neutron and releases a beta plus particle. So the difference is neutron going to proton versus proton going to neutron. So in a beta minus decay, the mass number will remain the same. There's the same number of nucleons, but there'll be an extra proton, an extra positive charge. And in beta plus decay, mass number remains the same, but since you're dropping the number of protons, you will actually get less charge on your nucleus than you had before. So, which radiation does not affect the element of the parent nucleus? Well, the only one is gamma, which just releases energy. All of the others, because they change the number of protons in your nucleus, alpha as well, where it gets rid of 2 protons in your nucleus, that is what affects your element number, the number of protons in your nucleus. Okay, explain which radiation is most dangerous across a classroom. Well, that would be which one is the most penetrating of the three. Gamma, it will be the only one that can actually reach you from that side of the classroom. This would be a different question if it asked which were the most dangerous and they were on you, because the most ionizing would be the most dangerous at that point. So it's only gamma in this example because the other two simply wouldn't even be able to reach you to cause you any danger in the first place. Okay, why are the most ionizing radiations the least penetrating? If they're more ionizing, then they're using energy to knock off more electrons, and so they don't make it very far through a material before all that energy is used and they are absorbed into that material. So most ionizing alpha, then beta, then gamma, means the opposite for penetrating. Most penetrating gamma, then beta, then alpha. Okay, what property of photographic film makes it a useful safety device? Well, it is because when radiation is incident on it, it darkens. It doesn't protect you against the radiation, but it helps you to monitor your level of exposure to radiation so that you can protect yourself by removing yourself from the area where that radiation is if that film gets too dark. Okay, a Geiger-Müller tube measures radiation in a classroom. It's all of it due to the radioactive isotope. Why/why not? Nope, it is not. Why? Because we have background radiation. That is radiation which is all present in every direction, and that will also be being counted on the Geiger-Müller tube. So you have this idea that whatever your count rate is on the Geiger-Müller tube, that is equal to the radiation from your isotope plus the radiation due to background radiation.
Before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
Okay, my tips and tricks for this section are doing the top line, bottom line of mathsing for these decay equations is underrated. I would definitely write it out, thing, make sure your arrow is an equal sign to thing. Why? Because mostly your beta plus and beta minuses, you would be maybe shocked by the amount of times that people get those the wrong way round if they don't write these out properly. It's a very easy but costly mistake to make in an otherwise relatively simple part of the spec. Okay, defining background radiation, you need to mention two things. The idea that it's everywhere, i.e. all around you or in every direction or something that says that, and at all times, so it's constantly there or at all times or something like that. So direction and time both need to be mentioned. Other thing is you have these other symbols that you can use for your alpha or beta. So that's meant to be a 4 at the top of that helium bit there. Instead of writing alpha, it could be He to signify helium nucleus, which is the same thing, happens to have 2 protons and 2 neutrons. And your beta plus and beta minus, because beta particles are essentially just high speed electrons and positrons, those are sometimes given just a symbol E, like an electron or a positron. And not to forget that it is possible that they ask you about these neutrons as well, and to be able to give those 1 and 0. If you were drawing a proton by itself, we'll do it very quickly actually, you would have a P and then you would have a charge of 1 at the bottom and 1 at the top for the mass number.